Sample problem 11-01. Signs are suspended from equal length rods on the side of a building. For each case, the mass of the cable compared to the mass of the rods is small and can be ignored. The mass of the sign is given in each figure. In cases B and D, the rod is horizontal. In the other cases, the angle the rod makes with the vertical is also given. Rank the magnitude of the torque the signs exert about the point in which the rod is attached to the side of the building. So we want to figure out the torque around the pivot point in each case. And so we're going to come back to, as always, that the torque of something is the r perpendicular times the f, where r perpendicular equals the shortest distance to the line of action. What is the line of action? The line of action is the line containing the force we're talking about. So for instance, jumping to the easy one, if I look at case B, the line of action, right, the force will be the weight of this thing pulling down. The sign will pull down on the rod, and its weight will be the force it exerts. And so the line of action is the vertical line at the end of the rod. And so for B, the torque is the length of the rod times the weight. We'll call it just times mg. So here it's going to be 100 g times L. And so on for the others. So I'm going to make a little chart so I can keep track of how much stuff is. I'm going to say I have around A, around B, around C, from D, and from E. And we just computed that B's is 100 GL. And the other one that's going to be easy to do, so I'll do it first, is D. I guess there is no E. D has this line of action because that's the force. And that length is also L, but it's only 900 it's only 90 kilograms, so that torque is going to be 90 GL. So I already got that B is greater than D. And then if we look at the other two, they'll be a little bit more annoying, but not in any way impossible. If I look at case A, this is the force, so the line of action is this vertical side. And then I have to say the shortest distance is this side, which I'll call RA. And we can see, going over here, that we have length L here. So this is 30 degrees, and I want this side when I have L, that's 30 degrees. So I have that the thing I want divided by hypotenuse. Well, the thing I want is the opposite side from 30. So I'm in the case of having sine. Sine of 30 turns out nicely to be a half. And so we get that RA is 1/2 L. Going back over here, then, we say the force would be 50 G, but the distance is only 1/2 L, so that's really just 25 GL. That. And then lastly, C. For C, this is the force, so that's the line of action, and we want that side, and we can see that that says that RC over L is sine of 60. The sine of 60 is about 0.86. So RC is actually √3/2, the sine of 60, times L. And so we end up having 50 G times √3/2 L, and that's 25 √3 L. And √3, like I said, is about 1.7. So 25 times 1.7 is sort of like just about 43. So we get about 43 GL. And now it becomes easy to just read off our answers. Our largest is B. And then the next largest is D. And then the next largest is C. And finally, A. And that ends up being the ranking that we're looking for.